4.4 part 2. We worked on graphing the functions yesterday, and today I'm going to show you that there's actually two different types of graphs, two different ways that you are going to have to draw them depending on the situation. So like this states, a graph might have solutions that are not actually on your table. A real world graph should show only the points that make sense in that given situation. Okay, so these are going to mostly be word problems so that you can see what the situation actually is. The two types of graphs that you're going to work with today are called continuous and discrete. Continuous means we connect all the dots. Every point that your line touches makes sense for your situation. A discrete graph means that only certain data points make sense, so we actually don't connect the dots. We just graph the dots and leave them as it is. Okay, we'll try a situation that has both, and we'll see if we can pick out which one is which. A local cheesemaker is making cheddar cheese to sell at a farmer's market. The amount of milk used to make the cheese and the price at which he sells the cheese are shown. Write a function for each situation, graph each function, and tell if the graph is continuous or discrete. All right, so let's start with this. 1 gallon of milk makes 16 ounces of cheddar cheese. Okay, the function rule that I'm going to write is y equals 16x. Okay, in that case, the y is going to be the gallons of milk that I use, and x is going to be the amount of cheese, like the total amount that I want. Okay, let's go graph that one. Okay, if I graph that one, or I'm going to pick some numbers to put in there. Do I need any 0 or negative numbers? I can't have negative amounts of milk. So I'm going to, if I have 0, then I have 0 cheese. So I'm going to start with 1. I'm just going to use 1, 2, 3, 4, 5. Let's see if I can make this a little bigger. Nope, it's not going to let me. Okay, so if I have 1, I plug in a 1. 16 times 1 is going to give me 16 ounces. 16 times 2 will give me 32 ounces. 16 times 3, 48, then 64, and then 80. Okay, now to decide if I need a continuous or discrete graph, is it possible that instead of using the full 16 ounces, or the full gallon of milk, is it possible that I maybe only use half a gallon? Or a quarter of a gallon, or anywhere in between? Yes, it's possible. So that means that when I graph this, I'm going to get a straight line that goes up, and I'm going to connect it because every point along the way is possible. I could have 0 milk, 0 cheese. I could use a half a gallon. I could use a whole gallon. I could use 17 gallons. Who knows? But all along the way, I could use any fraction of a gallon of milk, and it would still make me some cheese. So this one is called a continuous graph. Okay, if I'm talking about him selling his cheese, he makes these wheels, and each one costs $9. So my equation for that one is going to be y is equal to 9 times x. Okay, my y is going to be the total amount of money that he's going to make when he's selling these, and the x is how many wheels of cheese. Okay, so when I go to graph this, I don't need any negatives, and if I have a 0, it's going to be, I sell 0, I make $0, so 0, 0. Okay, the rest of them I'm just going to go 1, 2, 3, 4. If I sell 1 wheel of cheese, I make $9. 2 gets me 18, 3 gets me 27, and 4 gets me 36. Okay, true. Seems like it's going to be kind of the same as this one. But it's not quite, because if you look at his wheels of cheese, he's selling them as whole wheels of cheese. He's not willing to cut these in half and sell them for $4.50, or cut a chunk off and sell them for less. So in this case, this one is discrete. This is one where we would not connect the dots. Okay, if he sells 0 wheels of cheese, he gets $0. If he sells 1 wheel of cheese, he's going to make $9. 2 wheels, 18, 3 wheels, 27, 4 wheels, 36, but nothing in between. So that one stays just like this with dots, and that one is called a discrete graph. Okay, so let's talk about the difference. Discrete graphs are values that can be counted. Okay, I can count 9, 18, 27, 36. Those are easy to count, and that's going to give me a dotted graph. Okay, continuous graphs are values that can be measured. Notice how we measured in gallons, anywhere in between. We could measure in ounces how much cheese it was going to make, and that one's going to give us a solid line graph. Okay, one more example. If Megan buys eggs at the supermarket for $1.75 per carton, the cost is a function of the number of cartons bought. What is the graph of the function, and is it continuous or discrete? Okay, so we could make our XY chart. If I bought 0 cartons of eggs, it's going to cost me $0. If I buy 1, it's going to cost me $1.75. If I buy 2, it's going to cost me $3.50. Okay, but can I go to the store and grab a carton of eggs, usually they come in dozens, and just take like 4 of them out and walk up to the counter and pay for my 4 eggs? No. So that means I can't pick just any amount in between. I have to buy a whole carton, 1 whole carton or 2 whole cartons. So this one's going to be discrete. And when I graph it, it's just going to be in dots, no connecting. All right, so hopefully you can remember the difference between discrete, which I can count, and continuous, which I can measure, and you should be able to finish page 257 and lesson quiz 4.4 today. Page 257, 10 through 20 evens, 21 through 29, 34, 36, 37, and the full lesson quiz.